Here's a question about liquids. It says, find the density of seawater at a depth where the pressure is 300 atmospheres. If the density at the surface is 1,100 kilograms per meter cubed, salt water has a bulk modulus of 2.3 times 10 to the 9th newtons per meter cubed. Bulk modulus is defined to be, bulk modulus is, this is the initial density, this is the change in pressure, and this is the change in density, So I can solve this equation for the change in density and then add that to the initial density, and that would be the answer. So if I multiply both sides by change in density, I'll write density like that, and then I divide both sides. So that one up here, I divide both sides by the bulk modulus. So I got the change in density equals the initial density times the change in pressure divided by the bulk modulus. And my units, everything's good, kilograms and cubic meters. Newtons is kilograms per second squared and meters. So I've got my units good. So what is the change in pressure? Well, at the surface, it's 1 atmosphere, and it's going down to 300 atmospheres. So the change in pressure, or change in pressure is 299 atmospheres. And I've written this up here. 1 atmosphere is 101,325 pascals. So 299 atmospheres, that's the change in pressure, is a change of how many pascals? Cross multiply x equals 299 times 101,325. Now I'm going to do this in Desmos, so I'll just use that number for the change in pressure in Desmos. And let's see, and then I'll use it in the calculation. So 299 times 101,325. I have no idea what I wrote. So the change in pressure is 30,296,175 pascals. But anyway, so now I've got that's delta P. Delta P is this, change in pressure. So all I have to do is get the initial density, which is 1,100, times the change in pressure, which is 290. You can just write that number in, or I'm just going to keep building it in Desmos, so I'm just going to do it like this. And then divide it by the bulk modulus, which is 2.3 times 10 to the 9th. And then I can do that here. I can multiply this times 1,100 and then divide the whole thing by 2.3 times 10 to the 9th. And it comes out to about 14.489, approximately 14.489. Now I'm just going to use this whole calculation. That's the change in density, and to that, I will add that to the initial density. Because it doesn't ask for what the change in density is, it says find the density. So the density at this depth of 300 atmospheres, which is 299 atmospheres deeper under the water, is going to be the initial density plus that change in density. So it's 1,114.49 approximately. So the new density, the density at 300 atmospheres, is equal to 1114.49. That's approximately this whole thing times 1100 plus 1100. This plus 1100 is the exact answer as I did in Desmos. But that's the answer. So find the change in density, add it to the initial density, and that gives you the density at 300 atmospheres.